estimate for a mean. We did a point estimate for a proportion. We did a point estimate for a standard deviation. Why do we need a point estimate? It's $1 million question. Where did our point estimate come from? Where did we get that from? So when you do SX, like for instance, Amanda just said, where do I get the SX when I'm given like 10 pieces of data? You put it in your L1, you did a one-year stat, pulled up the SX, that's your point estimate. It represents what? Your sample standard deviation, right? So your point estimates come from your sample. Using your point estimates, you're going to make an inference about your population, where that parameter should fall, whether it be a mean or a proportion or a standard deviation. These are so that we can make a confidence interval where our proportion would fall from our population, or our standard deviation would fall from our population, because we don't know that. So we're going to make an inference about that. All right, so we're going to start with using our sample. Now, obviously, in a survey of 1,023 adults, aren't there more adults in the United States? So I use my sample, I make a proportion, this becomes my point estimate. If you don't get this point estimate, you miss the whole concept of setting up a confidence interval. I use this as my point estimate. From there, I can build my confidence interval. Obviously not from this statement, but if they gave us a margin of error. So say I said your margin of error was 0.02. So from here, I could take my p-hat and I could build my confidence interval. So now I would be confident that my proportion from my population would be somewhere between these two proportions, or in this case, 52% to 56%. My population would fall if they give me the rest of this information. But my point estimate is my starting point, is the information from my sample, so I can make an inference about my population. So all these, both of these just ask you to find your p-hat and q-hat. Can everybody find a p-hat and q-hat? Okay. You could also use your calculator for this step, and your calculator will give you a p-hat if you have your x and your n. You can build your confidence. Those of you that like the calculator, you can always put this in your calculator once we get to the confidence interval. I'm fine with that. So the one with the standard deviation does not have one. Okay. It tells us to find our confidence interval, and I'll do it on the calc in a second. So I will give you the formulas. What you have to remember is which formula to use. This guy has a p-hat and a q-hat inside. That should give you a good hint. Use this one. So, oops, I have to find my ZC. My ZC says 90%. Remember how we do this. We say in our inverse norm. Use your inverse norm for this. This is the same as looking up table 4. Use your inverse norm and use the positive number. Sometimes on the bottom of table 4, it gives you that little bracket down there. It'll give you the 90, 95, 99, and I think 80. From there, my margin of error, keep it as a decimal. Add it and subtract it from your p-hat. I want this worked out. Whether you leave it to me in this or you do this, either way is fine with me. Make an inequality. You can leave it as an interval. In your calculator, if you don't want to do this whole mess, you go to stats, you go to test, you come down to where the intervals are. I'm looking for not a z-score, not a t-score. I don't have two samples, no two samples. I have one proportion, and I'm using a z-score with this. So there's the guy I use, A. it says, what is your X? My X was, they didn't give me an X. I'm sorry, say that again. 552. And my N was 1026. 1023. Thank you. And I'm using a 90% confidence interval. Come down here and calculate. Now, it gives you your p-hat, so you can verify your p-hat. If you do this, just take your p-hat, 0.54, and subtract it from the higher one. Round this up first. If you're going to use 2 decimals, make sure everything is, excuse me, everything is rounded to 2 decimals. And then subtract, and you can find your margin of error. So if that rounds to 0.57, this rounds to 0.54, my margin of error is 0.03. So do I need to use that formula? Nope. If I give it to you in step by step, and I say find me the margin of error first, and you find the interval first, that's fine. Draw a little arrow, and then from there you found your margin of error. I'm okay with that. And then you're going to do the same thing here using a 98. So what we notice here, from a 90 to a 98, our p-hat was 0.54. This guy went 0.51 to 0.57. It had a margin of error of 3. This one is a little close, but it's going, is this the same numbers? No, different numbers. Different numbers, we can't do that. Sorry. I thought it was the same numbers, but different numbers. And you're getting your other margin of error. Oh, you had your, you did your p-hat, q-hat, so you just have to make your margin of error. Everybody remember these? This was before the break. You guys good with this part? And in your test, I'll do the same thing. You'll do the proportions, and then we'll go right into the standard deviation ones. I'll even tell you where the standard deviations start. Okay? When it's asking us to find, it's asking us to find the minimum sample size. It's asking for an n equals formula. Some of you have trouble with this. What is the question asking me? Right now, it didn't ask me anything. Up in the top, you wish to estimate with 95% confidence the population proportion of U.S. who thinks blah, blah, blah. Your estimate must be within, here's your margin of error of your population. Still didn't ask me anything. Then it says no preliminary estimates are available. Find the minimum sample size. So right away, go there and write your n equals. You don't have an n equals for standard deviation. So you're only going to get one n equals on your test. Preliminary means set it to 0.5, 0.5. I don't know any previous information. Figure it out there. What is the rule that we get with decimals? Round up. I'm going to hit you with 2 points again if you don't round up. Then they said, okay, now from a prior study, I found that the p-hat was actually 0.63. So because it's a little bit different, I should have a little bit less to use in here. A little bit less in my sample. Okay? Let me shut the door. Okay. All right, so make sure you know this part. And then we flip to the standard deviations. So the first thing I'll ask you to do is find me the critical value, just like the homework, for a chi-square. You're going to put this in your calculator the same way you do. However, we don't have a calculator set for this. But we have table 6. So this is going to become 0.02 divided by 2, 0.01. Its corresponding is 0.99. The area always adds up to 1. This comes off, if it helps you, make like an axis like that, because it's like your first quadrant. So therefore, that you remember, those all have to be positive. So I look these up. I use my degrees of freedom. The left, and if you look at the table, the left-hand side is the lower one. LLL, left, lower, less. The right-hand side is the greater one. It's just the way your table goes as well. Find me your critical values. Can everybody find the critical values? Amanda, you good? Yeah? Yeah? This is the critical part. This is the only hard part. That's the part that goes into your equation. Okay? We do 1 minus 90 divided by 2. We get a 0.05. Remember, your chart is symmetric. Make a little line down the 90 and 10. You notice all the 90s are to the left already. All the 10s and 00s are to the right. Find me the two pieces. Remember to do your degrees of freedom. It's a slight difference, but it's still a difference. The bad part about this one, the area is to the right. That's why the area is, the numbers are a little bit off. But I don't want you to think that. I just want you to constantly do the 1 minus 0.90 divided by 2 and use those. Questions? Okay. The weights of 17 randomly selected super zoom digital cameras are listed, 95% confidence. You want to find this, put this in your L1. You want this guy, the sample standard deviation. You do not want this guy. This is the population standard deviation. This is what you're making an inference about because you don't know it. Your calculator doesn't know that what you put in is a sample versus a population. So it gives you both. Because if you put this in your calculator and you say, oh, this was my population, then you can pull out your population standard deviation. But you know that you put it in as a sample. So you take your SX. Rule of thumb, at least give me 2 decimals. I tend to do 3, but at least give me 2 decimals on the standard deviations. The mean should be 1 more than the data, but that only gives us 1 decimal on the standard deviation. I kind of like at least 2. As long as your rounding is good, just don't round to a whole number on your standard deviations. You still have to go find your X2R and your X2L. Use your table. Use the fact that it's a 95 divided by 2, 0.025, 0.975. And remember, the larger one has to go here, the smaller one here. Because when you divide by a larger number, you get a smaller answer. If you divide it backwards, then just remember to flip this statement around. Don't flip your inequality signs. And then take the square root. Once we take the square root of a variance, we get a standard deviation. Now, what does this mean in words? And you know darn well I'm going to ask you this statement. I want to be 95% confident, and I'm looking for certain words. That the population standard deviation of these digital cameras will fall between this answer, 5.215 and 10.656. Now, keywords. I want to be 95% confident. That's why this is called the confidence interval. Keyword, population standard deviation. I am making this inference about a population. That's what this whole section has been on. So if you don't put the word population in there, it's wrong. If you leave it out as your sample, you already know. You would know exactly what your sample was. You wouldn't need to build a confidence interval for your sample. You're building your confidence interval for your population based on the point estimate of your sample. So you know I'm going to ask you to put those into words. Are you okay with this? And the last one, same thing, you're going to put it into your L1. You're going to give me Sx from your L1. I don't need a mean. You only use your sample standard deviation. Again, 1 minus 0.98 divided by 2. Use your two columns, 0.01, 0.99, degrees of freedom, and set up your equation. Can everybody set the equation up? I will give you that equation. This one looks bad, but I think it's really the least amount of work because the numerators are exactly the same. Degrees of freedom, standard deviation. Remember, if the problem gives you a variance, then do not square the variance because variance is your standard deviation squared. If the problem gives you a standard deviation, then you square it, right? That's the big difference. Questions? No? So you have like 10 minutes. Work on your vocab. Pull out your vocab sheet and get your vocab done. That's probably help you out. So, and as a matter of fact,